All right, today's lesson is going to be about multiplying and dividing square roots. So a product is what you get when you multiply, and a quotient is what you get when you divide. So that's what we're going to do today, and we're going to do it using square roots. And I have something a little non-mathematical here, but this is what's helped me in the past when I've learned these. Innies and outies, okay? So an innie is inside a radical. I call that an innie. If it's inside the radical, it's an innie. And they only multiply and divide with other innies. Okay, they only multiply and divide with other innies. And for outies, those are going to be outside the radical. And then same. Outies with outies, innies with innies, okay? All right, so it's not really something you'd see in a book or anything, but it's helped me in the past remember how to take care of radicals. So let's go ahead and practice some examples below. These are all multiplying, so we're going to be doing the product of these. Let's look at the first one here. So you should notice that 4 and 6 are outies, and root 3 and root 2 are innies. So we're going to do 4 times 6, and inside we do 3 times 2. So we have 24, and then square root of 6. You always want to check to see if there are any pairs here, and there are no pairs. So you are all done, okay? Let's skip over to 3. On number 3 again, we have outies here, and we have innies right here. So we would do the 5 times 6 for our outies, and we would do 3 times 3 for our innies. Just like that. So this is going to be 30 square root 9. But don't you know what the square root of 9 is? You can also break it up. It's 3. So this is just 30 times 3, and you have 90. So notice that the radical went away because the square root of 9 is 3. I ask that you do this, number 2, for practice and bring that to class with you. So if you can do number 2, it's very similar to 1 and 3, just slightly teeny tiny bit different. If you could do that and bring it to class, that would be wonderful. So let's keep going down here. Let's look at number 4. Now number 4 is a little interesting because it's squared. Well, think about what like x squared is. That's x times x, right? And think about what 3 squared is. That's 3 times 3, right? So if that's true, the square root of 7 squared must be the square root of 7 times the square root of 7, okay? So those are both innies, so we'll have square root of 49, and then the square root of 49 is 7. You also could remember that a square and a square root are inverses of each other, so they undo each other. On number 5, notice that the square is on everything in the parenthesis, and that's important. It's on the whole thing. So this means you're going to write 3 root 2 times 3 root 2. So now we've got our outies, and then we've got our innies. So we're going to have 3 times 3, and then the square root of 2 times 2, which will give us 9 root 4, and the square root of 4 is 2. So we get 18 here. Remember, if I'm going too fast, you can always pause this, rewind it, rewatch it, do whatever you need to do to understand the problem. Let's look at 6. Notice that my exponent is only on my radical. It's only on my radical, it's not on the 3. So that means this is 3 times square root 2 times square root 2. So 3 square root 4. The square root of 4 we know is 2. So the answer here is 6. So think about the difference between those two. It's where the parentheses are. So where the parentheses are. That's what makes the difference. So make sure that you pay attention to that because that does matter where the parentheses are. All right? So let's keep going here. There are some radical rules that you should know. These are 3 things that I always think about when I'm doing these problems. So never leave a pair under your radical sign. Never leave a pair under your radical sign. Remember that innies go with innies and outies go withouties. And then the last thing that might be totally new to you is you can have no radical in the denominator. Oops, I spelled that wrong. Denominator, okay? What you're going to have to do is something called rationalizing. Okay? You're going to have to rationalize it. So never leave a pair under the radical, innies with innies and outies with outies, and no radical in your denominator. That's going to be new for you, rationalizing. So to rationalize the denominator, we multiply both the top and the bottom by the square root that's in the denominator. Okay, that's going to be our new thing today. So let's look at this example. 3 over root 5. To get rid of root 5, we multiply the top and the bottom by root 5. So now we have 3 root 5. Now I'll put a little extra step in here. You have 3 root 5 over the square root of 25. But we know the square root of 25 is 5. And then you're done. Let's actually do that together for number 1. So we don't have any pairs inside of our radical. The innies go with innies, outies go with outies. We got all that. But let's talk about this radical in the denominator. To rationalize, you multiply the top and bottom by the radical that's on the bottom. So now we have 6 root 2 over root 4. But what is the square root of 4? The square root of 4 is 2. Now both of these guys are outies. These are outies right here. So 6 divided by 2 is 3. So 3 root 2 is our final answer. I want you to try number 2 on your own. It's very, very similar to number 1. Should be just as almost identical to number 1, just different numbers. Let's talk about 3. We have a radical on the bottom. So we know to rationalize, we multiply the top and the bottom by what's on the bottom. Just like that. So 8 root 7 over the square root of 49. But we know the square root of 49 is 7. Now these two outies here don't reduce at all. So you're actually done. And I have a lot of students that make the mistake of crossing these out, but that's an innie, that's an outie. So don't cross them out. Don't cross them out. Let's look at number 4. On number 4, I see that I have a 2 down here. Now when you rationalize, I want you to only multiply by the radical that's in the bottom, okay? So we'll have 3 root 20 over 6 root 4. But you know that the square root of 4 is 2. So 3 root 20 over 6 times 2. And we know that 6 times 2 is 12. So 3 root 20 over 12. And you could also reduce this if you want, but before I do that, let's talk about the 20. If we take 20 and we bust it up into a factor tree, it's going to be 4 times 5, and then we know that 4 is 2 times 2. So this right here would be 2 root 5 for your square root 20. So square root 20 is actually 2 root 5. Now let's multiply these together. They're outies. So 6 root 5 over 12, and then you would reduce these guys right here to root 5 over 2. And you're all done. Now that one was a tougher one, so if you need to rewatch it, I do encourage you to do that. If you need to do that, do that. I'm going to ask that you do number 5 for class. It's similar to 4, but it's actually a little bit easier than 4. There's less reducing in it, so hopefully it won't be too bad for you. So if you can finish up those 3 problems I asked you to do, bring them to class. We will discuss those then. Have a great night.